Oh gosh.
Everyone be quiet.
Oh wait, what's it?
Alright. Here you go, ladies and gentlemen. We have to finish this unit. It is very important. And so we are finishing up Unit 4. We have 3 days where we're doing some worksheets. And today's problems are Delta Math problems, and so I have to make some changes for sure. At the end of the packet. I think where your fingers are is where it is. Like, okay, no, yeah, one more, right there. One more. Turn to page. One more page, right there. There it is. Okay, so today we're looking at general exponential equations. How do I know something's an exponential equation? X in the exponent is exponential. Lots of X's. X in the exponent means it's exponential. And so we have lots of different looking problems, but we're all going to solve them the same way. So I thought I had to teach you the common base method, which is what you were tested on. If the bases match, so if you had b to the x equals b to the y, if the bases match, what must be true? Then x is equal to y, right? So that was the method that we learned before, but we might get something different now. We might have that. So we can solve all exponential equations this way by isolating the exponential expression and then taking a log, or in our case, we're just going to take a natural log of both sides. We just always use the common log, the natural log all the time. It just makes life so much easier. And check for extraneous solutions is always a good plan. We can always check, and that's the thing that's really quite nice. You can check your answers. So here I have a very simple exponential equation here. And what the problem is that x is way high. So we have to do something to drop it back down to earth, okay? And so to do that, we can take a natural log of both sides of our equation. And we have our log rules that say, hey, if there's a log, what do our powers do? Yeah, the power gets to drop down in front. And so we get x times the natural log of 3 equals the natural log of 80. And so we are taking logs so that we can drop our powers down, okay? Because I can't do anything when our x is in the exponent. Now, we got to get x by itself, so what do I have to get rid of? Divide. I want the x.
Oh wait. Divide by natural log of 3.
Then divide by the natural log of 3. So we get x equals the natural log of 80 over the natural log of 3, which is a perfectly wonderful answer. But we're going to go ahead and put it into our calculators. The natural log of 80 divided by the natural log of 3. And we get a lovely little approximation. 3 decimal places, please. So 3.989. 3.989, yeah? Okay. All right. Number 2. E to the x equals 140. I can't do anything when that x is up high. What's going to allow me to drop it down? Natural log. We're going to take a natural log of both sides. That allows me a power play, so my power gets to drop down. I get x times the natural log of e equals the natural log of 140. What is the natural log of e?
1.
Because why? What is natural log? Yeah, natural log, remember, is log base e. Log base e of e?
E. 1.
1. Why?
Because the log base of a log is... No, I don't know.
How do you drop a log? Give it a swirly. So e to the first power equals e. True, false? True. Okay. So, yes, log base e of e is 1. Ladies and gentlemen, what is log base 7 of 7? 1. What is log base 52 of 52?
1.
1. What is log base b of b? 1. Always. Okay. So the log of e, the natural log of e is simply 1. So x is all by itself. We get the natural log of 140. That is a perfect answer. It is completely exact. If I want an approximation, I can type in the natural log of 140 and get 4.942. All right. Okay. So I need you to change some problems. These are more like what you're going to see in Delta Math, so I apologize that I printed these before I was ready. So number 3 here is going to be 94 times 3 to the x equals 100. The first step in solving is to isolate the exponential expression. Divide by 94. Yeah, the exponential expression is right here. It is our base to our exponent. That is the thing we want to get all by itself. So what do I need to get rid of?
No.
94. So we're going to divide both sides by 94 so that our exponential expression is isolated. And then, let's see, 100, I'm just going to leave it 100 divided by 94 because I don't want to write that mess. So I'm just going to leave it 100 over 94 because it's perfect. Now, how do I drop my x? I need a natural log of both sides. So I'm going to take a natural log of both sides, and that's going to allow me to drop my power down. So I get x times the natural log of 3 equals the natural log of 100 over 94. And then how do I get x by itself? Divide by the natural log of 3. Divide by the natural log of 3. So x equals all this mess. So what I'm going to do is I'm going to type it in. Let's see, I have the natural log of 100 over 94. So that's my numerator, divided by the natural log of 3. All right, you got to use your calculator, please. Make sure you're getting it right. Make sure you're typing it in right. And we get 0.056 will do. I think you're going to have to read carefully on Delta Math to see what they want you to round to. So pay attention to read carefully. All right, number 4. Again, I've got a change for you. This is 3 to the 3x equals 94. 3 to the 3x equals 94. Yep, I got to take a natural log right off the bat. At my whole power, I'm going to drop down in front. So I have to take a natural log of both sides. That's going to give me 3x times the natural log of 3 equals the natural log of 94. How do we get x by itself? All right, I want to divide by the natural log of 3. What else do I need to get rid of? The 3, yes, I'm also going to divide by that 3 because it's 3 times x. So I want to get rid of that 3 as well. I can divide it. So we're going to divide by 3 natural log of 3. So x equals, now this one is very particular. I would say probably the best way to do this one is do the alpha F1 and get your fractions set up carefully. You do have to be exceptionally careful with something like this in your calculator. So the natural log of 94 over 3, natural log 3 is 1.378 will do, approximately. You'll notice here, if I type it in my way, which is the old school way, we didn't have that alpha F1 feature many, many moons ago. I would type it in with parentheses around the entire denominator. So you can do it that way and get the same result. But you'll notice what happens if I remove the parentheses. You're going to get something very different. Okay, so the parentheses matter a lot. What is this calculator doing? And it's dividing by 3 and then multiplying by the natural log of 3 instead of dividing by both. Okay, so those parentheses make a huge difference. So you have to be very, very careful. We can do number 5 here. We have e to the 3x plus 25 equals 108. What do you want to do first? Subtract 25. Very good. So we get e to the 3x equals 83. And then what should we do? Natural log. I'll take natural log of both sides, and that's going to allow us to drop our power down. So we get 3 times x times the natural log of e equals the natural log, of 83. What is the natural log of e? 1. How do we get x by itself? Divide by 3, divide by 3. So we get x is approximately, let's see, the natural log of 83 divided by 3. What are y'all getting? 1.473. Good. These are never going to give us exact answers. So this is a perfect exact answer. But if we plug it into our calculator, we should get 1.473-ish. Okay. All right. Number 6, I have 14. E to the x divided by 4 equals 168. Again, the problem change here. What do you want to do first? Divide by 14. Yes, divide by 14. Divide by 14. So we get e to the x over 4 equals 168 divided by 14. 12. Thank you. All right, then what should we do? Take a natural log of both sides. That's going to allow our power to drop down in front. So we get x divided by 4 times the natural log of e equals the natural log of 12. All right, what do we do now? We will. What's about the natural log of e? Oh, it's just 1. Hey, okay. So now we have x divided by 4, so how do we get rid of divide by 4? Multiply by 4. So I just I can put it right in front there is the best way to do it. Do you multiply the 4 times the 12 and get 48? No, because this is the natural log of 12. 12 is in the argument, so there's already some crazy function happening there. You don't want to multiply the 4 times the 12. We just stick it in front, 4 times the natural log of 12, okay? Remember, anytime you have a log, there's this whole swirly-gig process that's happening, okay? So really, we have to be very careful. For natural log 12 is an exact answer. It's perfect. It's beautiful. Or we can type it in and get an approximation, 9.9396, whoops-a-daisy, which would be 9.40, yeah. So, there we go. All right, how are you feeling about this? Okay? Pretty easy? Good. All right, let's skip to 9. Well, then, we can sort of do that. Let's start at 8, then. So we'll skip 7. I'm okay with that. What do you want to do first in number 8? Oh, sorry, I'll give you a chance to write it down. 17 equals 5 to the x minus 2 plus 6. 17 equals 5 to the x minus 2 plus 6. What do you want to do first? Subtract 6. Very good. We're going to subtract 6. That gives me 11 equals 5 to the x minus 2 power. Now what do we do? Natural log both sides. This is going to allow me to drop my power. So I get the natural log of 11 equals the entire x minus 2 times the natural log of 5. Be careful with your notation. This is really important. This natural log of 5 is affecting everything that was in the power. So be very careful. What do you want to do next?
Divide by natural log of 5.
Sure, we can do that. We can divide by the natural log of 5.
And then subtract.
We'll hold that thought there. So we have the natural log of 11 over the natural log of 5 equals x minus 2. Add 2. So the natural log of 11 over the natural log of 5 plus a big 2 equals x. This is, again, the exact answer. It's perfect. But if I put it in my calculator, the natural log of 11 divided by the natural log of 5, and then a big plus 2. 3.490, I guess I'd say. Approximately. Okay. All right. Are you feeling okay with this? All right. Let's look at number 9 and 10, and we'll be done. All right. Number 9 is 300 equals 9,780. Don't you love the numbers? Or the base of 0.905 raised to the x minus 4 power with a big minus 510 on the outside. Add 510. Yes, we're going to add 510 to get started. All right. So that's 810 equals 9780 times 0.905 to the x minus 4 power. Then, yes, we do have to get rid. This is being multiplied, so we're going to divide that off. God bless you. 9780 divided by 9780. Let's see if that is anything pretty or not. 810 divided by 9780. Ew. 27 over 326. I guess that's a little shorter to write, so we'll do that. 27 over 326 equals 0.905 to the x minus 4. So we did a little math frac there just so it's a prettier fraction. Natural log, so we can bring down our powers here. So this is the natural log of the entire fraction. So again, with parentheses, watch your notation so you're not confusing anybody. And this whole power is going to drop down in front. So I have the natural log of 27 over 326 equals x minus 4 times the natural log of 0.905. All right, what do you want to do now? Yeah, this is being multiplied in. We would have to distribute it, or I can just divide it off right here. So I can divide by the natural log of 0.905 to get rid of it, so I don't have to distribute it, so that's good. All right, and then I have this craziness. How do I get the x by itself? Add 4, yeah. So natural log of 27 over 326, all divided by the natural log of 0.905, and then a big plus 4. This is the exact answer. It is perfect. It is beautiful. You're not going to crash into the Mars rover or into Mars because this is exact. All right? You go and you round stuff off. It just messes everything up. 0.905. So there is my big old first fraction, and then my plus 4, and I get 28.955 approximately.
Nice.
Crazy, huh? All right. I don't think we need to do number 10. I think we're good.
Yeah, we're good.
We're good? Okay. Fabulous. I think it's adult math, actually, today.